In this video, let's talk about the relationship between the degree of homogeneity of a function and returns to scale. Suppose we have a production function or a function of f of x. This function of f of x is homogeneous of degree c f of tx is equal to t to the power of c multiplied by f of x. It means if we scale this function by t by a scalar of t, then f of tx, function after scaling, is equal to t to the power of c multiplied by f of x. Then this function is homogeneous of degree c. This is the power of t, and any value is that. So if f of x is a production function, suppose this x is a vector of inputs, and those inputs are labeled in capital, then f of x is equal to f of L and k. Then this function is homogeneous of degree c if f of TLTK, it means after scaling all inputs by some scalar of t, is equal to t to the power of c multiplied by f of Lk. And there is one condition for all t greater than 0. So now, based on the degree of homogeneity or the c, we will have different types of production function in terms of returns to scale. We may have constant return to scales, we may have increasing returns to scales, and we may have decreasing return to scale. And what are those conditions? First, if c is equal to 1, then f of tx is equal to t to the power of, instead of c, we will plug the value t to the power of 1 multiplied by f of x. So then what will be the result? The result, we will have that f of tx is equal to t multiplied by f of x. And based on the condition for the returns to scale, we have that if f of tx is equal to t multiplied by f of x, it means the function after scaling is equal to t multiplied by initial function. We will have, what we will have? You remember that we have constant returns to scale. We have constant returns to scale. But if c, it means the degree of homogeneity is greater than 1, then f of tx is equal to t to the power of c, but now this c is greater than 1. It's not more anymore equal to 1. It's greater than 1. T to the power of c greater than 1 multiplied by f of x. So in this case, f of tx, because the c is greater than 1, then f of tx is greater than t multiplied by fx. And based on the condition for the returns to scale, we have if f of tx is greater than t multiplied by fx, we have increasing returns to scale. And third one, if c is less than 1, it means the degree of homogeneity is less than 1, then f of tx will be equal to t to the power of c, but now c is less than 1, multiplied by f of x. In this case, we may have that f of tx is less than t multiplied by fx. So, you know that from the previous videos, from the previous lessons, we learned that f of tx, when f of tx is equal to t multiplied by f of x, in this situation, we have decreasing returns to scale. Again, let me explain. If the function has a homogeneous of degree 1, we have constant return to scale. If a function is homogeneous of degree greater than 1, we have increasing return to scale. This case, constant return to scale, this case, increasing return to scale. And if a function is homogeneous of degree less than 1, then we will have decreasing returns to scale. As a final thought, let's summarize the relationship between homogeneity and returns to scale. So, we may have a constant returns to scale production function if and only if. Remember that. We have a constant returns to scale production function if and only if production function is homogeneous of degree 1. This case, homogeneous of degree 1, we have constant return to scale. And we have increasing returns to scale if the production function is homogeneous of degree greater than 1. This case, which is C is greater than 1. And we may have decreasing returns to scale production function if it's homogeneous of degree less than 1. So this is the relationship between homogeneity or homogeneous of degree and returns to scale. So based on the value of homogeneity, we may have constant returns to scale, increasing returns to scale, or decreasing returns to scale. Thank you for watching. See you next time. Again, hope to subscribe my YouTube channel. Press the like button, write down your comment, and share my videos and YouTube channels to all other fellows in order to enjoy these lessons together. See you.